In this example, we are going to try and graph this without using a calculator, put all the pieces together that we can. We're going to take a pre-calc college algebra look to it and then add a calc look to it. So derivatives, second derivatives, see what kind of information that we can get out of all that. All right, so we'll start with doing kind of the college algebra calc thing in looking at, do we have any domain issues? And this is a polynomial, so this thing's going to go left and right forever, no domain issues whatsoever. And then we're looking at our end behavior. This is next to the fourth, so it kind of has a quadratic end behavior feel to it. Do we have y-intercepts? And so if we plug in 0, we get 0. And then x-intercepts is us taking this equation and setting it equal to 0. So x to the fourth plus 8, x to the third plus 18, x squared equal to 0. So if we factor this, or if we solve it, we're going to factor an x squared out, which is going to leave us an x squared plus 8x plus 18 equaling 0. Here we're going to get x equals 0 with the bounce because of the multiplicity. Okay, so we'll keep that in the back of our mind. That'll help us graph this. And then here we're going to try to solve it, but it is not factorable because there's nothing that multiplies to 18 that adds to 8. So we have to quadratic formula this thing. So plus or minus the square root of b squared, 64 minus 4 times b squared minus 4ac. So 4 times a times c. So that's going to be 72 divided by our a value. So we are getting an imaginary here. So plus or minus the square root of a negative 8. So since it's an imaginary, we are done with that. So that doesn't give us any additional x-intercepts. So we just have the one that's going to be a bounce. Right, so that's what we know so far. I do know that it's probably going to dip down and do some things in here, but let's get a little more detail to this. And that's where the calc stuff's going to happen. So we'll do our first derivative, which is going to be 4x cubed plus 24x squared plus 36x. All right, we'll take that and set it equal to 0 to try to solve it. So 4x to the third plus 24x squared plus 36x equals 0. Factor out a 4x. And then we get x squared plus 6x plus 9. And so if we set that equal to 0, we get a solution of 0. This factors into x plus 3 and another x plus 3. So x equals -3 and -3. All right, so we got critical numbers slope-wise, first derivative-wise of 0 and -3. Let's do our second derivative. See what critical numbers we get out of that. So if we do the second derivative, we're looking at a 12x squared plus 48x plus 36. We can take 12 out of that. So x squared plus 4x plus 3. Right, we jump in. Let's set it equal to 0 first, and then we'll factor it. So 12x squared plus 48x plus 36 equals 0. So us doing this is going to be checking for concavity and where we have any potential inflection points. So 4x plus 3 equals 0. 12 doesn't have a variable on it, so it's not going to give us a solution. And then this factors into, let's do this, x plus 3, x plus 1. So critical numbers, that doesn't give us anything. Critical numbers of -3 and -1. All All right, so let's go and put this into a number line. So we have first derivative. We have critical numbers at -3 and 0. So -3 and 0. Second derivative, we have critical numbers at -3 and -1. So I'm going to purposely put that on the inside of 0. All right, so go back to the first derivative. We're going to test out our factors. So we have, these are our 3 factors that we're looking at. We're going to plug in a number to the left of that. So if we plug in a -4 into this, we'll get a negative, negative, negative. All multiplied together would make a negative. We plug in -1, we'll get a negative, positive, positive, giving us a negative. And then if we plug in a +1, we get a positive, positive, positive. Positive. All right, so we have a negative slope transitioning to a negative slope, but hitting a slope of 0 somewhere in between. We have a negative slope transitioning to a positive slope, hitting a 0 slope somewhere in between. And then, so basically, if we connect that, we're going to put all that together. Then we have some concavity. So we have some concave up, concave down. So we should see that happening here. Here's our factors that we'll be plugging it into the second derivative. So like a -4 is going to be, the 12's already positive. So a -4 is going to get us a negative times a negative positive. So that's concave up, which lines up well with that. And then if I plug in between -3 and 1, I have like a -2. So if I plug in -2 in here, we're getting a positive, a positive negative. So that's concave down, which agrees. And then at -1, we have, so let's plug in a 0. So we get a positive, positive. So that's a positive. So we get concave up. So we have 2 points of inflection because you have, just like here, you have a transition from a negative slope to a positive slope. You have a transition of concavity from one concavity to another. So positive and negative is going to give us an inflection point at -3 and an inflection point at -1. All right, so if I graph a rough sketch of this without knowing y values, except for one point right there, I know that I'm going to get a 0, 0, and my critical values are -1 and -3. Right? We know that we have minimum at 0. Agreed. And then at -1, we have an inflection point, but it's concave up, so it's going to be higher. And then this is where it's going to shift. So concave up like that. And then at -1, it's going to shift to concave down until we get to 3 where it levels off. So here's concave down and it levels off to a horizontal because we have a 0 slope, and then it goes concave up again. Something along those lines. All right, so there's a total rough sketch of what that graph would be. If I really wanted some more accuracy to it, I would be taking those numbers and plugging them in and seeing what the y values that go with them, and then I could really plot that out very nicely. So that's using the first derivative, second derivative, and some pre-calc to kind of put all the pieces together and get a lot of information about that graph.